Welcome to the deep dive. You've really given us a fascinating stack of material, this time PDF excerpts, touching on all sorts of corners of Java development with the Spring framework.
hmm
It's clear you've been digging deep, and we're excited to unpack it all with you.
Absolutely. And with such a comprehensive set of resources, our mission today is pretty clear to really distill the core essence of the Spring framework as it's presented in your materials.
Right.
We want to cut through any potential information overload and give you a clear understanding of what makes Spring tick, what problems it solves, and why it remains such a cornerstone of Java development.
Exactly. So, where are we headed on this deep dive? We're going to start right at the foundation, looking at the core principles like inversion of control, which seems to be a recurring and crucial theme in your sources.
Yeah, it's central.
Then we'll explore how Spring helps in building web applications, touching on MVC and REST.
Okay.
Data handling is obviously crucial, so we'll unpack Spring's approach with JDBC and JPA.
Mm.
And finally, we'll look at some of the ways Spring enhances applications with things like AOP, SPLL, caching, and even security. All of this is, of course, grounded in the specifics of the material you shared. Okay, let's unpack this. What's at the very heart of Spring? This fundamental shift we keep seeing referenced.
What's fascinating here is that your sources highlight a real shift in Java development philosophy. They introduce the concept of plain old Java objects, or POJOs.
POJOs, right?
This term, as your materials point out, was actually coined by Martin Fowler, Rebecca Parsons, and Josh McKenzie. The idea was to move away from the complexities of older models, particularly Enterprise Java Beans, or EJBs.
EJBs.
Think of it as a return to simpler, more focused Java objects.
Right, the EJBs. Your sources mentioned they came around in '97, offering a distributed component model. But it sounds like they brought their own set of headaches, didn't they?
Oh, definitely.
Figure 1 to 2 in your materials really illustrates this physical layering with separate web and EJB containers, even if they were on the same server. What were the core issues that POJOs and Spring aim to solve?
Precisely. If we connect this to the bigger picture, the EJB model often led to web and service layers interacting via remote method invocation, or RMI.
Or am I? Okay.
This, as your material notes, could create performance bottlenecks and even class loader complexities because the EJB container and the web container use different class loader instances.
Right, like two separate worlds almost.
Exactly. Figure 1-2 visually reinforces how this could feel like crossing physical boundaries even within the same machine. The headaches really stemmed from this complexity and the heavy, often cumbersome nature of EJB components themselves, leading to slower development and deployment cycles.
So in comes Spring with a different approach. Lightweight containers and this concept of inversion of control, or IOC. It sounds like a fundamental shift in how components are managed.
This raises an important question. Instead of objects creating and managing their own dependencies, IOC flips that.
Okay.
The Spring container takes on the responsibility of creating and wiring together these application components, which are often referred to as beans.
Beans, yeah.
This is where dependency injection, or DI, comes in. It's the mechanism by which the container supplies those dependencies. Think of it as the container injecting the necessary dependencies into your objects.
So the control is inverted. The container controls the dependencies.
Precisely. Your materials emphasize that when IOC is mentioned today, it's almost always understood to mean dependency injection. It fundamentally changed Java development by promoting looser coupling and making code much more testable.
And it seems the way you even configure this dependency injection has evolved within Spring itself, hasn't it?
It has.
Your sources mention a move from XML schemas in version 2.0 to leveraging Java 5 annotations around version 2.5 for things like auto-discovery and auto-wiring.
That's a key point. The introduction of annotations like @component allowed Spring to automatically detect beans, and @autowired simplified the process of injecting dependencies, reducing the need for verbose XML configuration.
Less XML is often good.
Definitely. But your sources also detail the Spring IOC container's fundamental role.
Hmm.
It's responsible for instantiating these beans, initializing them, and managing them throughout their lifecycle, essentially acting as the central authority for object creation and management in your application.
Now, when we talk about configuring these beans, your material mentions different ways to do it. You can still use XML, but it looks like Java-based configuration is a popular alternative, using @configuration and @bean annotations.
Right.
The Chi2 bean configuration example for an account bean seems to illustrate this nicely.
Exactly. @configuration marks a class as a source of bean definitions, and methods annotated with @bean within that class will produce and register beans within the Spring container.
Okay, so the class says I define beans, and the methods say, here's a bean.
That's a good way to put it. And it's not just about creation. Your sources also detail how dependencies are injected. We see setter injection, which happens after the bean is created,
After creation.
and constructor injection, where dependencies are provided as arguments to the constructor during the bean's instantiation.
So right when it's being built.
Exactly. The try it out examples for constructor injection really bring that to life, showcasing how dependencies are baked right into the object's creation.
It's interesting how even bean definitions themselves can be overridden.
Hmm.
The overriding bean definitions try it out with configuration 1 and configuration 2 classes, and that foo bean really shows how the order of configuration can matter.
It really can.
It seems like the later definition can take precedence. Could that also lead to unexpected behavior if you're not careful with your configuration order?
Oh, absolutely. That's a crucial detail and a great point. Spring processes the configuration metadata, and in cases of duplicate bean definitions, the one loaded last often wins.
Right.
This can be really useful for tailoring configurations in different environments, but it absolutely carries the risk of unintended overrides.
So what are some best practices to avoid such issues?
Well, best practices include maintaining a clear and well-organized configuration structure, potentially breaking down large configurations into smaller logical units.
Makes sense.
Using more explicit bean naming can also help avoid accidental clashes. Your materials also introduce at depenson,
That depends on, okay.
which gives you explicit control over the order in which beans are created, which can be important when one bean relies on another being initialized first, further reducing the risk of unexpected behavior due to implicit ordering.
And then there's auto-wiring, letting Spring automatically figure out the dependencies. Your sources mention different modes like by type, by name, and constructor. It sounds like a real time saver during development as the code base evolves.
Auto-wiring can significantly reduce the amount of explicit configuration needed. By type, for instance, injects a dependency based on its type, while by name looks for a bean with a matching name. Constructor auto-wiring lets Spring resolve dependencies through the constructor arguments. But your materials also cover different ways to actually instantiate beans beyond just using the default constructor.
Right, like factory methods.
Exactly. We see static factory methods and instance factory methods illustrated with those bean examples for foo3 and foo4 using foo-factory.
Okay.
And of course, the annotation-based equivalent using @component or @configuration along with @bean mirrors this flexibility. It shows Spring's commitment to supporting various object creation patterns.
Your sources also briefly touch on scoped beans and lazy bean creation. It seems like Spring offers quite a bit of control over the lifecycle and instantiation of these components.
Absolutely. Scopes allow you to define how many instances of a bean should exist, like singleton or prototype.
Singleton prototype, right?
And lazy initialization can improve startup time by deferring the creation of a bean until it's actually needed, which can be a significant advantage in larger applications.
Faster startup is always good.
Definitely. And going beyond just creation, your materials mention lifecycle callbacks. Although at post-construct and at pre-destroy aren't explicitly named, the concept of initialization and destruction phases for beans is definitely there, allowing you to hook into specific points in a bean's life.
Now, what about tailoring your application's behavior for different environments, like development, testing, or production?
Profiles.
It seems Spring has a way to handle that too, with bean definition profiles using @profile and the beans profile in XML. The configuring the application environment at runtime, try it out, really highlights this.
This is incredibly useful. Profiles allow you to define different sets of bean configurations and activate them based on the runtime environment.
Like using a different database for dev versus prod.
Exactly that. You might have a different data source bean for your development database versus your production database. Your sources also introduce the environment abstraction in Spring 3.1.
Okay, the environment abstraction.
Which provides a more comprehensive way to manage environment-specific configurations, giving you programmatic access to environment properties and profiles.
So more control there too.
And for even more advanced customization, your materials briefly touch on Spring's factory bean interface, which allows you to customize the object creation process itself, giving you very fine-grained control.
Wow. Great.
Finally, it's interesting to note how beans themselves can interact with the application context by having it injected directly, giving them programmatic access to the Spring containers facilities.
Okay, so Spring provides this powerful foundation for managing our application's components. Now let's move into building web applications. Your sources introduce Spring MVC and the model view controller pattern.
MVC.
For those who might not be familiar, what are the key parts of MVC and how does Spring implement it?
The MVC pattern, as your materials explain, helps to structure web applications into three main parts. The model, which handles the application's data and business logic.
The data part.
The view, which is responsible for displaying the data to the user.
What the user sees.
And the controller, which acts as an intermediary, handling user input and updating the model and view accordingly.
The traffic cop.
Sort of. Spring MVC provides a robust framework built around this pattern to simplify web development.
And it seems Spring MVC has a central figure in this process, the dispatcher servlet.
Okay.
Your sources describe it as the handler for all incoming HTTP requests.
The front controller, yeah.
And they even give an example of URL mapping with .mvc. It then figures out which controller should handle the request using handler mappings, like request mapping handler mapping.
That's right.
It's interesting that default annotation handler mapping was deprecated in Spring 3.2 in favor of request mapping handler mapping. So the dispatcher servlet is like the air traffic controller for our web application. Now, how does it actually figure out which of our controllers should handle a specific request coming in?
That's a great analogy. The dispatcher servlet acts as the front controller, routing requests to the appropriate handlers. It uses handler mappings, like request mapping handler mapping, to determine which controller and which method within that controller are responsible for handling a given request based on the URL, HTTP method, and other criteria defined by annotations like @request mapping.
Okay, based on the request details.
Exactly. And your materials rightly emphasize that Spring MVC is view agnostic. You're not tied to just JSPs.
Right, that's important.
You can use other view technologies like Velocity, Tiles, FreeMarker, and XSLT. This is why Spring MVC introduces its model architecture and avoids direct coupling to HTTP servlet requests, offering a more flexible and testable approach to rendering responses.
It looks like annotation-based configuration extends to Spring MVC as well. Your sources mention using @configuration and @bean to set up things like the internal resource view resolver.
Absolutely. Just like with core Spring Beans, you can configure your Spring MVC application context using Java-based configuration, defining beans like the internal resource view resolver, which helps locate your view files based on configured prefixes and suffixes.
Like finding your JSPs in the right folder.
Precisely. And to make working with views easier, especially JSPs, Spring provides its own tag library as indicated by the % at taglib.uri http.www.springframework.org, tags form, prefix, MVC %, and % at taglib.uri http.www.springframework.org, tags, prefix, Spring % directives.
The taglibs are
offering convenient ways to bind data to forms and access localized messages.
Now, one of the things that really stood out in the material is the power of binding in Spring MVC. It sounds like user data from the views can be automatically tied to the model.
Or data binding.
Your sources mention command objects, form objects, and form backing objects. What's the benefit of this automatic binding?
What's fascinating here is how Spring MVC simplifies the process of taking user input from web forms and converting it into Java objects. This binding mechanism automatically matches request parameters to the properties of your model classes.
So no manual parsing.
Exactly, saving you from manually extracting and converting data. The MVC.input tag with its path attribute is a prime example, automatically linking a form field to a specific property in your model, even setting the id and name attributes based on that path.
That sounds much cleaner.
It dramatically reduces boilerplate code and makes it easier to work with form data in your controllers.
And it looks like Spring even handles data formatting. Your sources mention a datetime format for java.time.localDate, which is great for working with dates without a lot of extra configuration.
Yeah, it's super helpful.
It even handles default short datetime formats and allows for customization with ISO and pattern.
That's right. Spring 4.0, as your materials later highlight, provides excellent support for Java 8's java.time API. A datetime format makes it incredibly easy to control how dates and times are displayed and parsed in your web forms.
Nice.
Your sources also cover handling radio buttons with MVC.radioButton and MVC.radioButtons, highlighting the path, value, and label attributes, and even binding to lists of enum values using items genders.
Oh, binding to enum's neat.
It streamlines the process of creating complex forms and handling various input types.
So how do we actually handle the form submissions? Your sources explain using @request mapping on controller methods, for example, for form to show the form and result to process it.
Right.
It also mentions creating model and view instances
Sure.
to pass data to the view.
The controller is where the action happens.
Hmm.
At request mapping on methods map specific HTTP requests to those methods. The model and view object is a container that holds both the model data,
The data to show.
the information you want to display in your view, and the name of the view to be rendered.
Okay, data and view name together.
Exactly. And the MVC.form tag with its model attribute and action attributes provides a convenient way to define your HTML forms and link them to your Spring MVC controllers.
Got it.
The example table within the form, showcasing MVC.label, MVC.input, MVC.radio buttons, MVC.select, MVC.checkbox, and the submit button, really brings together the form handling aspects, illustrating how all these tags work together to create interactive web forms.
It seems like the model attribute annotation is quite powerful too, both at the method level for loading reference data and at the method argument level for accessing the user-submitted data.
At model attribute provides a flexible way to populate the model with data that's needed by your views. At the method level, it can load things like a list of countries or genders, making them available to all views served by that controller.
Like preloading drop-down options.
Exactly. At the argument level, it allows your controller methods to directly receive the data submitted by the user through the form, neatly packaged into a Java object.
Now, how do we ensure that the data the user submits is actually valid? Your sources introduce the Bean Validation API and annotations like at size, at email, at credit card number, and at pattern on user class.
Validation, yeah, crucial.
It even mentions Hibernate Validator as an implementation and its Maven dependency.
Yeah.
Why is this validation step so important?
Data validation is crucial for any web application to prevent invalid or malicious data from being processed. Spring MVC integrates seamlessly with the Bean Validation API,
Okay.
allowing you to define validation rules using annotations on your model classes, ensuring data integrity right from the start. Then you need to enable validation in Spring MVC, often using MVC.annotation-driven validator.
And to show those validation errors in the view, it looks like we use MVC.errorsPath field name. And we can even style the error fields with Corsair class form field error. It's great that it's so integrated, providing direct feedback to the user.
It is. And to make your validation messages more user-friendly, especially for a global audience, Spring supports internationalization.
I18N. Right.
Your materials explain message source configuration using reloadable resource bundle message source with a base name like classpath.messages. This allows you to define validation messages in different languages in your properties files.
So different messages for different languages.
Exactly. It's interesting to note that implicit keys for validation messages take precedence over the annotation's message attribute, offering a convention over configuration approach.
Ah, okay.
However, it's also important to remember the caveat mentioned in your sources that Hibernate Validator might not have had full support for Java.time, local date validation at the time of writing, so you might have needed custom validators for that specific type in older versions.
Good point. What about handling file uploads? That's a pretty common requirement in web applications.
File uploads.
Your sources mention both Commons file upload and Servlet 3.1 multi-part request processing. How does Spring simplify this?
Spring provides support for both. To enable file uploading, you typically need to configure a multi-part resolver bean. For Commons file upload, it's usually Commons multi-part resolver. And you can set properties like upload tempdir, max upload size, and max in-memory size to control how uploaded files are handled. Spring handles the complexities of processing multi-part requests, allowing you to easily access the uploaded files in your controller methods.
And inevitably, things can go wrong. How does Spring MVC handle exceptions?
Exception handling.
Your sources explain using addExceptionHandler in controller classes, with an example of a user not found exception. What's the benefit of handling exceptions within the controller?
Spring MVC offers a robust exception handling mechanism. You can define methods within your controllers annotated with addExceptionHandler to handle specific types of exceptions that might occur within that controller.
So catch specific errors there.
Right. This allows you to gracefully handle errors and return custom error responses to the user, rather than relying on the default servlet container error pages.
Better than a generic error page.
Much better. Your materials also discuss global exception handling using @controller advice and response entity exception handler, which allows you to centralize exception handling logic across multiple controllers for more consistent error handling.
@controller advice for global handling.
Yeah.
Got it. Finally, for web applications that might serve a global audience, internationalization, I18N, is key.
Mm-hmm.
Your source's detail using a local resolver like session local resolver with a default locale, a local change interceptor with a param name like lang, and the spring.message tag in JSPs.
Yeah, all the pieces for I-18N.
And it looks like theming is also supported with theme source, theme resolver like session theme resolver, remembering the specific B name, theme resolver, theme change interceptor with a param name like theme, and the spring.theme tag in JSPs.
Theming too, yeah.
It's interesting that cookie theme resolver is also an option for stateless applications.
Yeah.
Why are I-18 and theming so important for a good user experience?
Spring MVC provides comprehensive support for both internationalization and theming, allowing you to tailor the user experience based on locale and visual preferences.
Makes sense.
The local resolver determines the user's locale, the local change interceptor allows users to switch locales, and the spring.message tag helps display localized text.
Right.
Similarly, the theme resolver and theme change interceptor work for managing application themes, allowing for visual customization. Providing applications in users' own languages and allowing for visual customization significantly improves usability and overall user satisfaction.
Okay, we've covered how Spring helps build web applications. Now let's shift gears and talk about data access. Your sources introduce Spring's JDBC support and mention various tools like JDBC template, name parameter JDBC template, and others.
The data layer, yes.
What's the fundamental role of JDBC in all of this, and what challenges does Spring aim to address with its JDBC module?
JDBC, or Java Database Connectivity, is the standard Java API for interacting with relational databases. Your materials explain that while it provides a standardized way to connect and work with databases, the SQL itself might still be specific to the database vendor.
Right. SQL can vary.
However, JDBC4 drivers do support ANSI SQL 2003 to a large extent. While JDBC offers direct database interaction, it can be quite verbose.
Yeah, lots of boilerplate.
Involving a lot of boilerplate code for tasks like connection management, statement creation, and result set processing. Spring's JDBC module provides powerful abstractions like JDBC template to dramatically simplify these operations and handle resource management for you, reducing the risk of common errors like forgetting to close connections.
So JDBT template handles the messy parts.
Pretty much, yeah. It cleans things up considerably.
Your sources discuss obtaining JDBC connections using Driver Manager and Data Source, and it recommends Data Source. Why is that the preferred approach?
Data Source is preferred because it's a more flexible and robust way to manage database connections. It allows you to abstract away the connection details, and it's the foundation for connection pooling and transaction management,
Connection volume.
leading to better performance and scalability. Your materials even show an example of Driver Manager Data Source configuration using @configuration and @bean. However, it's crucial to heed the caution in your sources against using Driver Manager Data Source in production due to the lack of connection pooling.
Big warning there.
Definitely. Libraries like C3P0 or Apache Commons DBCP or JNDI lookup for application server managed data source instances are much better choices for production environments, as they provide connection pooling, which significantly improves database interaction performance.
It's interesting that Spring even provides a way to initialize your database using JDBC.initializeDatabase. It looks like you can specify a data source and the location of your SQL scripts, and even control if it's enabled. When would you typically use something like this?
That's a really convenient feature for setting up your database schema and initial data, especially in development, testing, or during application startup.
Like seeding data for tests.
Exactly. You can point it to your SQL files, and Spring will execute them after the data source bean is created. The enabled attribute allows you to conditionally run these scripts, for example, only during development or testing phases. This can be very helpful for ensuring a consistent database state for your application.
Now, when it comes to actually performing data access operations, JDBC template seems to be a key player. What makes it so much simpler than working directly with JDBC?
JDBC template is a central class in Spring's JDBC support. It simplifies many of the low-level details of working with JDBC, such as handling connections, statements, and result sets, reducing boilerplate code that you typically have to write with raw JDBC.
Less code, fewer bugs, hopefully.
That's the idea. It also takes care of exception handling, converting JDBC-specific exceptions into Spring's more consistent data access exception hierarchy.
Consistent exceptions. Good.
Your materials illustrate using prepared statement creator factory and keyholder for inserting data and retrieving generated keys, which is a common scenario.
Getting back the auto-generated ID.
Right. Your sources also mention other useful classes like named parameter JDB template for working with named parameters in your SQL queries, improving readability.
Naming parameters are nice.
Simple JDB insert and simple JDB call for simplifying interactions with database metadata and stored procedures, and mapping SQL query, SQL update, and stored procedure for encapsulating database operations as reusable Java objects.
So that's JDBC. What about object relational mapping, or OM? Your sources introduce JPA as a standard for OM in Java and mention the paradigm mismatch between object-oriented and relational models.
Ah, the ORM impedance mismatch.
What are some of the key challenges this mismatch presents, and how does JPA aim to bridge that gap?
The paradigm mismatch refers to the fundamental differences between how we model data in object-oriented programming, with concepts like inheritance and complex associations, and how data is structured in relational databases, primarily through tables with rows and foreign keys.
Objects versus tables.
Exactly. Your materials highlight issues like mapping inheritance hierarchies to tables and handling complex, especially polymorphic associations. JPA, the Java Persistence API, aims to bridge this gap by providing a standard way to map your object model to the relational model, handling much of the translation and data management for you.
Your sources explain that JPA, the Java Persistence API, offers several benefits over using proprietary ORM tools directly, such as automatic metadata discovery, standardized configuration, and data access. It aims to provide a consistent way to map your object model to the relational model. What does automatic metadata discovery mean in this context?
Automatic metadata discovery means that JPA providers can often infer the mapping between your Java entities and database tables based on annotations and naming conventions, reducing the need for extensive manual configuration.
So it can figure things out on its own sometimes.
To some extent, yes, this simplifies the development process and makes it easier to get started with ORM.
Your sources explain defining entities with @entity and @table annotations. And when it comes to the attributes within those entities, it notes that they are persistent by default, but can be excluded with @transient or the transient modifier.
Right, controlling persistence.
It also discusses mapping attributes to columns. So it sounds like you're essentially annotating your Java classes to tell JPA how they correspond to your database schema.
Exactly. JPA uses annotations to define how your Java entities map to database tables and columns. @entity marks a class as a persistent entity. @table allows you to specify the table name, and annotations on your fields define how they map to columns. @transient tells JPA to ignore a particular field during persistence operations.
And when it comes to those associations, your sources explain @oneTune with @joinColumn, @manyTune with @joinColumn, and the optional false attribute, and @onetomany with @joinColumn, and the use of Java collection API types like set, list, collection, and map.
Defining relationships, yeah.
It seems like JPA provides a rich set of tools for defining these relationships. Why is it important to correctly define these associations?
It does. These annotations allow you to define the cardinality and ownership of relationships between your entities. For instance, @joinColumn specifies the foreign key column used to link related tables.
Okay.
Correctly defining these associations is crucial for JPA to manage relationships between your objects in the database, enabling features like lazy loading and cascading operations, and ensuring data integrity across related entities.
Right. Affects how JPA behaves.
Absolutely. The choice of collection API type in @onetomany can influence the behavior and performance of your application when dealing with collections of related entities.
Once you've mapped your entities, how do you actually perform database operations with JPA? Your sources mention using Entity Manager obtained via Entity Manager Factory for things like persisting, finding, merging, and removing entities.
The Entity Manager, yes.
It's interesting to note that only associated entities can be removed, not detached ones. What's the difference between an associated and a detached entity in JPA?
The Entity Manager is the central interface for interacting with the persistence context in JPA. It provides the methods for performing the basic CO, create, read, update, delete operations on your entities.
CRADOPS.
An associated or managed entity is one that is currently being tracked by an Entity Manager. A detached entity, on the other hand, is an entity instance that was once managed but is no longer associated with any entity manager.
So it's kind of outside the manager's control.
Right. You need to reattach a detached entity using merge before you can perform operations like removal on it.
Your sources also introduced JPA query language, or QL, as a way to query using entity names and properties instead of table and column names.
JPA QL, yes.
The example of creating and executing a query with entitymanager.createQuery and getResultList to get single result Looks much more object-oriented than writing raw SQL. What are the advantages of using JPA-QL?
JPA-QL provides an abstraction over SQL, allowing you to write queries in terms of your entity model. The JPA provider then translates these queries into the appropriate SQL for your database.
So it's database independent.
Mostly, yes. This makes your code more portable across different databases as you're not tied to specific SQL syntax. It also makes your queries more object-oriented and easier to understand in the context of your application's domain model.
How does Spring integrate with JPA? Your sources mentioned configuring local container entity manager factory bean for the entity manager factory and using add persistence unit for injecting it.
Spring and JPA work well together.
What's the role of local container entity manager factory bean?
Spring provides excellent integration with JPA. Local Container Entity Manager Factory Bean is the standard way to set up your JPA provider like Hibernate or Eclipse Link within a Spring application.
Okay, it sets up the JPA provider.
It handles the creation and configuration of the Entity Manager Factory, which is the factory for creating Entity Manager instances. The @persistence unit annotation allows you to easily inject the Entity Manager Factory into your Spring-managed components, while @persistence context is used to inject an Entity Manager directly.
Transaction management is crucial for data integrity. Your sources explain Spring's transaction management for JPA using JPA Transaction Manager and the @enable transaction management and transactional annotations for declarative transaction management.
Transactions, very important.
How does Spring's transaction management simplify working with JPA transactions?
Spring's transaction management provides a consistent way to handle transactions across different data access technologies, including JPA. JPA Transaction Manager is Spring's implementation of the Platform Transaction Manager interface specifically for JPA. @enable transaction management enables Spring's declarative transaction management, allowing you to use @transactional on your service layer methods to define transactional boundaries without having to manually manage transaction start, commit, and rollback operations,
Less manual transaction code.
leading to cleaner and more maintainable code.
Your sources also briefly mention enabling load time weaving, using context.loadTimeWeaver in XML or @enable load time weaving in Java config for bytecode enhancement. What's the purpose of that?
Load time weaving allows JPA providers to perform bytecode enhancement on your entity classes after they are loaded by the class loader but before they are used.
Enhancing the classes on the fly.
Essentially, yes. This can enable features like lazy loading of related entities and automatic dirty checking, improving performance and simplifying development in certain scenarios.
Finally, your sources provide a helpful list of key JPA annotations and Spring JPA-related annotations and classes. It seems like a comprehensive overview of how Spring supports JPA.
That summary provides a quick reference to the most important JPA and Spring JPA concepts, making it easier to navigate and understand how they all fit together. The mention of meta-nf-persistence.xml as the default JPA configuration file and javax.persistence. Persistence for loading it is also important for understanding JPA configuration, and Spring's persistence exception translator helps to convert JPA-specific exceptions into Spring's more generic data access exception hierarchy, providing a consistent exception handling strategy across different data access technologies.
Okay, data access is clearly a key area where Spring provides a lot of value. Now let's dive into transaction management itself. Your sources explain the importance of database transactions for data integrity and the ACD properties. Atomicity, consistency, isolation, and durability.
ACD, the foundation.
Atomicity, where all operations succeed or all are rolled back, is highlighted as a unit of work. Why are these properties so critical for maintaining data integrity?
Database transactions are fundamental for ensuring data consistency and reliability. As your materials point out, atomicity guarantees that a series of operations within a transaction are treated as a single unit.
All or nothing.
Exactly. If any part of the transaction fails, the entire transaction is rolled back, preventing partial updates and maintaining data integrity. Consistency ensures the database remains in a valid state after a transaction. Isolation controls how concurrent transactions interact with each other, and durability ensures that once a transaction is committed, the changes are permanent.
Right.
These properties are essential for preventing data corruption and ensuring the reliability of your database operations.
Your sources then discuss transaction demarcation, the process of starting, committing, and rolling back transactions. It notes how different data access technologies have their own APIs for this, and it even shows a simplified JDBC example of manual transaction management.
Manual demarcation, yeah.
It sounds a bit cumbersome to manage transactions directly like that. What are the risks of managing transactions manually?
Managing transactions manually can be error-prone and adds boilerplate code to your data access logic. As your materials illustrate with the JBBC example, you have to explicitly start the transaction, execute your operations, and then either commit or roll back based on the outcome.
Easy to forget a step.
Very easy. It's easy to forget a crucial step, like committing or rolling back, which can lead to data inconsistencies or resource leaks. This complexity increases significantly when dealing with multiple data access operations within a single transaction.
This leads to Spring's transaction abstraction model based on the Platform Transaction Manager interface. It sounds like Spring aims to provide a standard API to manage transactions regardless of the underlying data access technology.
That's the goal, yes.
Your sources emphasize that developers decide which implementation to use, resulting in a transaction manager bean definition. What are the benefits of this abstraction?
Exactly. Spring's Platform Transaction Manager acts as an abstraction layer, shielding your application code from the specifics of different transaction management mechanisms. Whether you're using JDBC, you interact with Spring's Transaction Management API.
One API for all.
Right. You simply need to configure the appropriate Platform Transaction Manager implementation for your chosen technology. This provides a consistent programming model for transaction management, making your code more portable and easier to maintain.
Your sources highlight the advantages of this abstract model, isolating code from specific data access technologies, making it easier to switch or even use multiple technologies within the same transaction. It sounds like a real benefit for flexibility and maintainability.
That's a key advantage. By relying on Spring's transaction abstraction, your business logic doesn't become tightly coupled to a particular data access framework's transaction API.
Less coupling is good.
Definitely. This makes your application more adaptable to future changes in technology. You could potentially switch your underlying data access technology with minimal changes to your transactional code.
Now let's talk about how Spring actually manages these transactions. Your sources introduce declarative transaction management using the @transactional annotation or XML configuration with tx.advice.
Declarative transactions, yeah.
It explains how Spring uses AOP to apply transaction management, creating a proxy around transactional methods. This sounds much cleaner than manual transaction management. How does Spring's AOP handle the transaction lifecycle?
Declarative transaction management simplifies transaction management significantly. You simply annotate your service layer methods with @transactional, and Spring's AOP framework automatically handles the transaction lifecycle, beginning the transaction before the method execution and committing or rolling back afterward.
Based on exceptions.
Exactly, based on whether exceptions are thrown. Spring creates a proxy around the annotated method. Before the actual method is invoked, the transaction is started. After the method completes, either successfully or with an exception, the proxy intercepts the execution and commits the transaction if no exception occurred, or rolls it back if an exception was thrown.
So the proxy wraps the method call.
Precisely. This keeps your business logic clean and free from transaction management concerns. Your materials show a main class example that demonstrates activating annotation-based transaction management with @enable transaction management.
The @transactional annotation seems quite configurable. Your sources show examples on an account service simple class, including class level and method level annotations with attributes like read-only and rollback for.
Lots of options.
It looks like you can really fine-tune the transactional behavior.
You have a lot of control with @transactional. You can apply it at the class level to make all public methods transactional by default, and then override the settings at the method level as needed. Attributes like read-only can optimize read-only operations, and rollback allows you to specify which exceptions should trigger a rollback, giving you granular control over transaction boundaries and behavior.
It's interesting that you can even programmatically trigger a rollback within a @transactional method using transaction aspect support .current transaction status .set rollback only.
Yeah, manual rollback trigger.
It provides a way to handle specific error conditions within a transaction. When might you need to do this?
That's a more advanced technique for situations where you need more fine-grained control over the transaction outcome based on specific business logic within your transactional method.
Right.
For example, you might catch an exception, perform some cleanup operations, and then decide to mark the transaction for rollback based on the nature of the error.
Figure 6.1 in your sources illustrates the concept of a single physical transaction spanning multiple method calls and the potential for unexpected rollback exception if an inner method marks the transaction for rollback, but the outer method attempts to commit.
Ah, yes, the rollback surprise.
That's a crucial point to understand.
This highlights the importance of understanding transaction propagation. When one transactional method calls another, they might participate in the same physical transaction.
Okay?
If an inner method sets the transaction to rollback only, the outer method cannot subsequently commit it, leading to an unexpected rollback exception. It's like an inner decision affecting the entire unit of work.
This brings us to transaction propagation rules. Your sources list several options like required, requires new, nested, and others, summarized in Table 6.2.
Propagation rules, yeah.
It seems like these rules dictate how transactions behave when methods call each other. Could you give a brief, relatable analogy for one or two of these key rules?
Sure. Transaction propagation rules define how transactional methods interact with existing transactions. Required is the most common. It either joins an existing transaction or creates a new one if none exists, like joining an existing conversation.
Okay, join or start.
Requires new always creates a new transaction, suspending the current one if there is one, like starting a completely separate phone call, even if you're already on one.
Always new. Got it.
Understanding these rules is key to correctly managing transactional boundaries in your application.
Your sources also provide an example of XML-based declarative transaction management using tx.advice and aop.config. It looks like you can define transaction attributes for specific methods using point cuts.
XML config is still an option.
Is there a reason why you might choose XML-based configuration over annotation-based or vice versa?
Well, while annotation-based configuration is often preferred for its conciseness and proximity to the code, XML-based configuration can be useful in situations where you want to define transaction boundaries without modifying the source code.
Right, without touching the Java code.
Or when dealing with cross-cutting concerns that apply to a large number of methods. It can also offer a more centralized view of your transaction management configuration. However, annotations are generally considered more convenient and easier to work with for most use cases.
Finally, your sources discuss programmatic transaction management, using transaction template recommended, and direct use of platform transaction manager, lower level.
Programmatic options, yeah.
The transaction template with the transaction callback looks like a cleaner way to define transactional code if you need more explicit control. When might you need programmatic transaction management?
Programmatic transaction management gives you fine-grained control over transaction boundaries within your code. Transaction template simplifies this by providing a template method that handles the transaction lifecycle for you, while you focus on the actual transactional operations within a transaction callback.
So template handles the boilerplate.
Exactly. It's particularly useful for managing transactions within methods where declarative transaction management might not be sufficient, for example, when you need to perform transactional operations conditionally within a larger non-transactional context. The transaction definition allows you to configure transaction properties programmatically, giving you even more control.
Okay, so Spring provides a lot of flexibility in managing transactions. Now let's move on to testing. Your sources outline covering configuring and caching application context, injecting test fixture dependencies with @autowired, working with transaction management in tests with @transactional,
Testing, crucial stuff.
testing web applications with @webapp configuration, and using mock objects. It sounds like Spring provides a comprehensive testing framework. Why is testing so important in the context of Spring applications?
Spring's test context framework provides a rich set of features to support various types of testing, from unit tests to integration tests. Testing is absolutely crucial for ensuring the reliability, stability, and correctness of your Spring-based applications.
Can't ship without tests, right?
Ideally not. It allows you to verify that your components work as expected, that your integrations are sound, and that your application behaves correctly in different scenarios. Spring's testing framework makes it easier to set up and manage the Spring context in your tests, inject dependencies, and perform various testing tasks efficiently.
Your sources explain configuring the test context framework using JUnits @runwith, Spring's unit for class runner.class, and Spring's @context configuration to specify the configuration metadata sources.
The basic setup, yeah.
The example with @autowired account service and an assertion looks like a basic integration test. So @context configuration is how we tell Spring which beans to load for our tests.
That's the foundation of Spring's testing support. At runwith, Spring unit for class runner.class sets up the testing environment to work with Spring, and @context configuration tells Spring where to load your application context from, essentially specifying the bean definitions that should be available during your tests.
So it spins up a mini Spring environment for the test.
Exactly. This allows you to inject your Spring-managed beans into your tests using @AutoWired and verify their behavior. Your materials note that if no locations are provided to at context configuration, Spring will look for a file named testclass-name-context.xml in the same package as the test class, offering a convenient default.
It's interesting that you can even use at configuration and at import resource within a static inner class to import XML-based configurations in annotation-driven tests.
Mix and config styles, yeah.
It seems to offer flexibility. Why might you want to do something like that?
That's a useful way to reuse existing XML configurations within your annotation-based tests. If you have a legacy application or a module with a lot of XML configuration, you can import those configurations into your newer annotation-driven tests without having to rewrite everything.
Okay, bridging the gap.
It provides a bridge between different configuration styles within your test suite.
Your sources also introduce active profiles for activating specific bean definition profiles during testing. This seems very helpful for testing different environment-specific configurations.
@active profiles, super useful.
Can you give an example of when you might use this?
@active profiles allows you to specify which Spring profiles should be active during your tests, enabling you to test how your application behaves with different sets of bean configurations.
Like testing against an in-memory database.
Exactly. You might have a test profile with an in-memory database configured. By using @ActiveProfiles test on your test class, you ensure that the tests run against this in-memory database, isolated from your development or production databases.
There's also mention of configuring application context using the application context initializer interface and the initializer's attribute of @context configuration. That sounds like a more programmatic way to set up your test context.
It is, yeah. More code-based setup.
When might you prefer this over just specifying configuration files?
Application Context Initializer provides a way to programmatically configure the application context before it's fully initialized, giving you more fine-grained control over the setup process.
Okay.
This can be useful for tasks like setting up embedded databases programmatically, configuring environment properties dynamically, or performing other initialization steps that are difficult to achieve through just configuration files.
And for larger projects with many test classes, your sources discuss inheriting context configurations using base test classes and @context configuration on child classes. It looks like the configurations are merged.
Inheritance helps reuse, yes.
How does this inheritance help in managing test configurations?
Context configuration inheritance helps to reduce duplication and promotes code reuse in your test suite. You can define common configurations, like setting up a shared data source in a base test class, and then child test classes can extend it and either add to or override the configuration as needed.
Keeps things DRY.
Exactly. This makes it easier to manage test configurations across a large project and ensures consistency.
Now, how does transaction management work in tests? Your sources explain using @transactional to make a test method transactional and automatically rolled back by default.
Test transactions, yes. The default rollback is key.
That's great for keeping your test data clean. Are there any scenarios where you wouldn't want the transaction to roll back automatically?
@transactional is a powerful annotation for managing transactions in your tests. By default, any transaction started within a test method annotated with @transactional will be automatically rolled back after the test completes, ensuring that your database remains in a consistent state between tests.
Clean slate for the next test.
Right. While rollback is the default and often desired behavior for isolated testing, there might be scenarios where you want to test transactional behavior itself, for example, verifying that data is committed correctly under certain conditions.
Testing the commit logic.
In such cases, you might configure @transactional to not roll back, although this should be used cautiously to avoid polluting your test environment. Your sources also introduce @before transaction and @after transaction for setup and teardown code that runs before and after a transactional test method.
Okay.
Although it's important to note that these only work within an active transaction.
It looks like you can even customize this transaction behavior using @transaction configuration to specify the transaction manager bean name and the default rollback commit behavior.
@transaction configuration provides more control over transaction management in your tests, allowing you to specify which transaction manager to use if you have multiple, and whether to commit or roll back transactions by default at the class level.
For testing web applications, your sources introduce a web app configuration to load a web application context in standalone integration tests.
@web app configuration for web tests.
It mentions how mock servlet context is created behind the scenes, with a default base resource path of Oric main web app, which can be overridden. Why is it important to load a web application context specifically for testing web components?
At web app configuration is essential for testing your Spring MVC applications in a standalone environment. It sets up a web application context, which is a special type of application context that is aware of web-specific components like servlets and filters.
So it knows about web stuff.
Exactly. It also provides a mock servlet context, allowing you to test your controllers, views, and other web components without deploying to a full-fledged servlet container, making your web integration tests much faster and easier to set up.
Faster tests are better tests.
Absolutely. Your sources also show an example of a web application test with @autowired web application context and mock servlet context, and an assertion to check if they are injected.
It's also mentioned that testing request and session scope beans in standalone integration tests becomes easier with web app configuration. How does it facilitate that?
Yes, web app configuration facilitates the testing of beans with web-specific scopes like request and session by providing a mock web environment.
Okay, it mocks the web environment.
You can simulate HTTP requests and sessions within your tests, allowing you to properly test the behavior of beans that depend on these scopes.
Finally, your sources introduce the concept of mock objects in unit testing as substitutes for real dependencies that don't interact with databases or networks.
Mocking, fundamental for unit tests.
It explains that mock objects can be trained and their state verified after the test. This is a core concept in effective unit testing. What are the key benefits of using mock objects in your tests?
Mock objects are invaluable for isolating the unit of code you're testing from its dependencies. By using mock objects, you can control the behavior of those dependencies and verify that your code interacts with them correctly without relying on external resources, which can be slow, unreliable, or difficult to set up.
Isolates the component under test.
Exactly. This makes your unit tests faster, more focused, and more deterministic. You can also verify that your code is making the correct calls to its dependencies.
Okay, let's shift our focus to aspect-oriented programming, or AOP. Your sources introduce it as a way to handle cross-cutting concerns by separating them from core business logic.
AOP, yeah. A different way of thinking about code structure.
What are some typical cross-cutting concerns and why is it beneficial to separate them?
Cross-cutting concerns are aspects of your application that tend to span across multiple modules or layers. Examples include logging, security, transaction management, and performance monitoring.
Things that pop up everywhere.
Right. AOP provides a way to modularize these concerns and apply them consistently throughout your application without tightly coupling them to your core business logic. This separation of concerns leads to cleaner, more maintainable code, as changes to a cross-cutting concern only need to be made in one place rather than throughout your code base. Think of it as keeping your core business logic focused on what it does best, while AOP handles the supporting actors in a modular way.
Your sources explain key AOP concepts: aspect, advice, join point, and point cut. Could you elaborate on each of these using a simple analogy?
Sure. An aspect is like a reusable module that implements a cross-cutting concern, such as logging.
The logging module.
Advice is the specific action taken by an aspect at a particular join point. Think of it as the when and what of the cross-cutting concern, like before a method executes, log something.
The action itself.
A join point is a specific point in the execution of your application where an aspect can be applied, such as the execution of a method.
Where the action can happen.
And a point cut is an expression that selects one or more join points where the advice should be executed. It's the way you specify where the logging should happen. For example, all public methods in the service layer.
The where selector. Got it. Your sources show an example of Spring AOP using XML configuration to log execution times. It defines a bean for the advice, a point cut using the execution designator, and an advisor linking them.
Classic logging example.
The execution point cut seems to target all public methods. How specific can you get with these point cut expressions?
That's a classic example of using AOP for logging. The execution point cut designator allows you to be very specific about which methods should be intercepted based on their signature, including return type, method name, arguments, and declaring class.
Pretty granular control then.
Very. You can use wildcards to match multiple methods or classes, or you can specify exact signatures. AOP offers a very powerful and flexible way to target specific points in your application's execution flow.
The material describes different types of advice. Before, after returning, after throwing, after finally, and around.
Different timings for the advice.
Around advice as a method interceptor sounds particularly powerful as it gives you complete control before and after the method invocation using preceding join point. When might you choose around advice over the other types?
Each type of advice executes at a different stage of the join point's execution. Before, advice runs before the method. After returning, runs after a successful method execution, allowing you to access the return value.
Okay.
After throwing, runs if an exception is thrown, allowing you to handle or log the exception. After, finally runs regardless of the method's outcome, like a finally block.
Right.
Round advice is indeed the most powerful, as it surrounds the method invocation and allows you to execute custom logic before and after, and even control whether the original method proceeds by calling preceding join point.proceed.
You can stop the original method.
You can, yeah. You might choose around advice when you need complete control over the method execution, such as for performance monitoring where you need to record the start and end times, or for implementing custom security checks that can prevent the method from executing altogether.
Your sources also introduce Aspect-J as another AOP framework that can be used with Spring, often using annotations like at aspect and at around.
Aspect-J, yeah. More powerful.
And the Gizmo provided looks quite similar to the XML configuration, but uses annotations directly in the aspect class. What are the key differences between Spring AOP and Aspect-J?
Aspect-J is a more comprehensive and powerful AOP framework than Spring AOP. It offers a richer set of point-cut expressions and supports weaving aspects at compile time, load time, and runtime.
More weaving options.
Whereas Spring AOP primarily uses runtime proxies. Spring AOP is generally simpler to configure and use for common AOP tasks within a Spring application, while Aspect-J provides more advanced features and tighter integration with the weaving process.
So Spring AOP is simpler, Aspect-J more powerful?
That's a good summary. Spring AOP integrates with Aspect-J and allows you to use Aspect-J annotations, leveraging Aspect-J's more powerful point-cut language.
To enable Aspect-J support in Spring, it seems you use @enable aspect autoproxy in a @configuration class.
@enable aspect autoproxy is the annotation that tells Spring to process classes annotated with @aspect and create the necessary proxies to apply the advice. It essentially enables Spring's integration with Aspect-J's annotation-based aspect declaration.
Finally, your sources mention the add_declare_parents annotation for introduction, which allows you to dynamically make target objects implement an interface.
Introduction, yeah, that's more advanced.
That sounds like a more advanced AOP feature. Could you give a practical example of when you might use this?
Introduction is a more specialized AOP technique that allows you to add new interfaces and their implementations to existing classes without modifying the original classes themselves. @declare_parents is the Aspect-J annotation used for this purpose within a Spring context.
Adding new abilities to existing classes?
Kind of like that. A practical example might be adding a monitorable interface with methods for collecting performance metrics to a set of existing service classes without modifying their original code. The aspect would then provide the implementation for the monitorable interface, effectively introducing new behavior to the target objects.
Okay, AOP provides a powerful way to handle cross-cutting concerns. Now, let's delve into the Spring Expression Language, or SPAL.
Fun stuff.
Your sources introduce it as a way to query and manipulate objects at runtime within Spring applications, noting its simple syntax and extensive features. Where is SPL typically used within a Spring application?
SPL is a powerful expression language that allows you to access and manipulate objects, properties, and methods within your Spring applications at runtime. It's used extensively throughout the Spring ecosystem.
Where specifically?
Including in bean definitions for injecting values, in Spring security for defining access control rules, in Spring data for defining repository query methods, and in caching annotations for defining cache keys and conditions.
So it pops up in lots of places.
It really does.
Your sources show an example of using SPAL in XML-based bean definitions with the property element and hashtag syntax to inject a system property. It also mentions system properties as a reserved word.
The hashtag syntax.
Yeah. How does SPEL make configuration more dynamic?
That's a basic but useful example. The hashtag syntax denotes a SPAL expression. System properties is a built-in variable that allows you to access system properties by name. SPEL makes configuration more dynamic by allowing you to inject values based on runtime conditions, environment variables, other bean properties, or even the results of method calls, rather than being limited to static values in your configuration files.
It looks like you can also use the @value annotation for SPL expressions on fields, constructors, and methods.
At value, very common.
Is there a preference between using @value and XML-based configuration for SPAL?
At value provides a convenient way to embed SPL expressions directly into your Java code for injecting values into fields, constructor arguments, or method parameters, often making the configuration more concise and co-located with the code that uses the injected value.
Puts the expression right there in the code.
Right. The choice between @value and XML-based configuration often comes down to personal preference and the specific context. Annotations are generally favored in more modern Spring applications, but XML can still be useful in certain situations, such as when you want to configure third-party libraries without modifying their source code.
For more programmatic use, your sources explain creating a SPELL parser, spell expression parser, and an evaluation context, standard evaluation context, and then using parser.parseExpression and get value to evaluate expression.
Programmatic SPAL, yeah.
When might you need to use SPLL programmatically?
When you need more dynamic expression evaluation beyond what can be achieved through annotations or XML configuration, you can use the spell expression parser to parse a string expression into an expression object and then use a standard evaluation context to evaluate that expression against a specific object or context.
It's like evaluating user input as an expression.
That could be a use case, yeah. Or implementing custom logic that involves evaluating expressions based on other runtime data.
Your sources demonstrate accessing system properties at system properties java.version and system environment variables at system environment java home in SPELL. It's good to know you have access to these.
SPLL provides access to both system properties and environment variables through the @system properties and @system environment variables, respectively, allowing you to configure your application based on the environment it's running in.
You can even define inline lists in SPLL and it shows examples of both simple lists and lists of lists. How is this useful in configuration?
SPLL allows you to define lists directly within your expressions using curly braces. This can be useful for configuring collection properties of your beans directly within your configuration, such as a list of allowed values or a list of target servers.
Defining a list right in the @value, maybe.
Exactly.
It's interesting that you can register custom functions in SPLO using context.register function with a method object, like registering stringutils.capitalize. How does this extend the capabilities of SPLL?
SPLL's extensibility allows you to register your own Java methods as functions that can be called within your SPL expressions. This can be very powerful for encapsulating reusable logic within your expressions, making them more expressive and allowing you to perform more complex operations directly in your configuration or annotations.
Your sources list various SPL operators, including arithmetic, relational, logical, conditional, ternary, and Elvis, and collection operators, selection and projection, providing examples for many of them.
Lots of operators.
The Elvis operator, as a simplified ternary operator, looks quite handy.
SPLO provides a rich set of operators for performing various operations within your expressions. The Elvis operator is indeed a concise way to provide a default value if the left-hand operand evaluates to null,
Nice shortcut for null checks.
leading to cleaner and more readable expressions. Collection, selection, and projection are powerful for querying and transforming collections within your expressions, allowing you to filter and extract data from lists and maps.
You can even access string beans in SPEL using the prefix before the bean name, although it notes that a bean resolver needs to be registered in the evaluation context.
Referencing other beans, yeah.
How does this facilitate interaction between beans during configuration?
SPEL's integration with Spring allows you to reference and access other Spring-managed beans within your expressions using the symbol. Spring contexts typically automatically register a bean resolver. This allows you to create dependencies and configure bean properties based on other beans in your application context, providing a powerful way to wire your application together.
For web views, your sources mention using the spring.eval tag in JSPs to evaluate SPEL expressions. When would you use this in a web application?
The spring.eval tag provides a way to execute SPEL expressions directly within your JSPs, allowing you to dynamically access and display data from your model, call methods on beans, and perform other operations directly in your view layer.
Running SPEL right in the JSP.
Yeah, this can be useful for complex data rendering or dynamic content generation within your web pages.
SPEL expressions can even be used in caching annotations, like @cacheable key. How does this make caching more flexible?
SPEL's ability to access method arguments makes it very useful for defining cache keys dynamically based on the input to your cached methods. In the @cacheable key #8 example, the cache key is generated based on the value of the id parameter of the method.
Using the method argument for the key.
Exactly, allowing you to cache results based on specific inputs. This makes caching much more flexible and targeted.
Finally, your sources list key SPL-related classes and concepts, and it cautions that SPL expressions are string literals, so there's no compile time type safety.
Important caveat.
That's an important thing to keep in mind.
That's a crucial point. Because PL expressions are evaluated at runtime, you don't get the compile time checks that you would with regular Java code. So careful testing is important to ensure your SPL expressions are correct and behave as expected.
Now let's talk about caching. Your sources introduce it as a mechanism to store data for faster retrieval, and show an example of enabling Spring's caching abstraction using cache, that annotation driven in XML, and defining a cache manager bean.
Caching for performance, yeah.
Why is caching so important for application performance?
Caching is a vital technique for improving application performance by reducing the need to repeatedly fetch data from slower sources like databases or external services.
Avoid hitting the database every time.
Exactly. By storing frequently accessed data in a faster cache, you can significantly reduce response times and improve the overall scalability of your application. Spring provides an abstraction layer over various caching providers, making it easier to integrate caching into your application. The cache.annotation-driven tag enables Spring's annotation-based caching.
You can also enable caching with annotations using @enable caching on a configuration class and defining a cache manager bean. It seems like you have a choice between XML and annotation-based configuration.
The flexibility again, yeah.
What are some common cache manager implementations you might use?
Yes, Spring offers flexibility in how you configure caching. @enable caching is the annotation-based equivalent of cache.annotation-driven food. You also need to define a cache manager bean, which is responsible for managing your application's caches.
Okay, the cache manager.
Some common implementations include Simple Cache Manager for basic in-memory caching, Concurrent Map Cache Manager, which also uses java.util.concurrent,
Simple in-memory ones.
and integrations with more advanced caching providers like Guava Cache Manager, integrating with Google Guava Cache, and Hazel Cache Manager for distributed caching with Hazelcast.
Distributed caching options too.
Right. So while Simple Cache Manager is great for basic in-memory caching, if you need more advanced features like distributed caching, Hazel Cache Manager would be the way to go, essentially offloading the caching responsibilities to a dedicated cluster.
The @cacheable annotation is key for caching the result of a method. Your sources explain the value attribute for the cache name and the key attribute, often using SPL expressions, for the cache key.
@cacheable, the main one.
It also mentions key generator and conditional caching with the condition attribute. How does using SPL for the cache key provide more control?
@cacheable is the core annotation for adding caching behavior to your methods. When a method annotated with @cacheable is called, Spring first checks if the result for the given key is already in the specified cache. If so, it returns the cache result. Otherwise, it executes the method, caches the result, and then returns it.
Cache hit-or-miss logic.
Exactly. SPL expressions in the key attribute provide a powerful way to customize how cache keys are generated based on method parameters, allowing you to create composite keys or derive keys from nested object properties, offering much more flexibility than just using a single method argument.
More complex keys possible.
Right. The condition attribute allows you to specify whether the result should be cached based on a SPL expression, giving you fine-grained control over when caching should occur.
Your sources caution against using @cacheable and @cacheevict on the same method for the same cache. That makes sense to avoid immediate eviction of what you just cached.
That's right. Combining @cacheable and @cacheevict for the same cache on the same method would typically negate the benefits of caching, as the newly cached result would likely be immediately evicted.
@cacheevict is used for removing entries from the cache, with attributes like key, all entries, and before invocation.
Kicking things out of the cache.
And @cacheput always executes the method and updates the cache with the result. When would you use @cacheput versus @cacheable?
@cacheevict allows you to remove specific entries or clear the entire cache. The before invocation attribute lets you control whether the eviction happens before or after the method execution.
Okay.
@cacheput is useful when you always want to execute the method and update the cache with the result, regardless of whether the data was already in the cache.
Always update the cache.
Right. You might use @cacheput in scenarios where the underlying data has been modified and you want to ensure the cache is updated with the latest value. @cacheable, on the other hand, only executes the method if the result is not already in the cache.
@caching acts as a group annotation to combine multiple @cacheable, @cachevict, or @cacheput annotations on a single method. That seems like a good way to manage more complex caching scenarios.
Grouping annotations, yeah.
Can you give an example?
When you have multiple caching operations that need to be performed for a single method call, @caching provides a way to group them together, making your code cleaner and more organized.
Okay.
For example, you might want to update multiple related caches whenever a certain method is called. You could use @caching to combine multiple @cachevic annotations, each targeting a different cache.
Finally, your sources briefly describe different cache manager implementations like Simple Cache Manager, No-Op Cache Manager, Concurrent Map Cache Manager, Composite Cache Manager, and mention Guava Cache Manager and Hazel Cache Manager.
Different cache managers.
It's interesting that Hazel Cache Manager refers to another bean as its wrapped cache manager.
Spring provides various cache manager implementations to suit different needs. Simple Cache Manager is a basic in-memory cache manager. No-Op Cache Manager essentially disables caching, useful for development or testing.
Turning caching off easily.
Concurrent Map Cache Manager uses java.util.concurrent map as the underlying cache. Composite Cache Manager allows you to manage multiple cache managers. Guava Cache Manager integrates with Google Guava's caching library, and Hazel Cache Manager provides integration with the distributed caching framework Hazelcast, often wrapping an existing Hazelcast instance to manage caches within a Hazelcast cluster.
Okay, we've explored caching. Now let's move on to building RESTful web services with Spring MVC. Your sources introduce REST and the use of HTTP methods for zero-ret operations.
REST APIs, very common now.
What are the key principles of REST, and how does Spring MVC facilitate building RESTful APIs?
REST, or Representational State Transfer, is an architectural style for building web services that emphasizes stateless communication between client and server, the use of standard HTTP methods like GET, POST, PUT, and DELETE for performing operations on resources identified by URLs.
Standard HTTP method.
And the transfer of resource representations like JSON or XML. Spring MVC provides excellent support for building RESTful services through its annotation-based controller model and built-in support for content negotiation and message conversion.
Your sources show an example of a @REST controller with @request mapping for various URLs and HTTP methods. @path variable is used to extract data from the URL, and @request body to access the request body.
The core REST annotations, yeah.
It also mentions using response entity to control the HTTP response status. How do these annotations simplify RESTful API development?
@REST controller is a specialized controller annotation that combines @controller and @response body, indicating that the methods in the controller will return data directly in the response body, often in formats like JSON or XML.
Made for APIs.
Making it ideal for building REST APIs. @request mapping maps HTTP request to handler methods based on URL and HTTP method. @path variable extracts values from the URL path, and @request body binds the incoming request body to a method parameter.
Getting data.
The response entity gives you fine-grained control over the entire HTTP response, including the status code, headers, and body, allowing you to build well-formed RESTful responses.
It briefly mentions configuring dispatcher servlet in web.xml and the Spring MVC configuration file with context.components-scan and MVC.annotation driven. It also notes using tools like SoapUI for testing REST services.
Basic setup and testing tools.
Why are tools like SoapUI helpful for testing REST APIs?
Setting up Spring AVC for REST involves configuring the dispatcher servlet in your web.xml to handle requests and enabling Spring MVC's annotation-driven features in your application context. Context.component-scan tells Spring to look for your controller classes, and MVC.annotation-driven enables support for annotations like @REST-controller, @request mapping, @path variable, and @request body, as well as message converters for handling different data formats.
Okay.
Tools like SoapUI are invaluable for testing RESTful services, as they allow you to send various HTTP requests with different HTTP methods, headers, and request bodies to your API endpoints, and inspect the full HTTP responses, including status codes, headers, and response bodies.
Simulates a client perfectly.
Making it easy to verify that your API is working correctly.
Your sources also provide an example of annotation-based configuration for REST services using @configuration, @enable web MVC, and @component scan.
Java config for REST setup. @enable web MVC is an annotation that enables Spring MVC's web support when using Java-based configuration. At component scan is used to specify the packages where Spring should look for your components, including your at-rest controller classes, providing a clean and efficient way to configure your REST API.
When things go wrong in your REST services, how do you handle exceptions? Your sources explain using add exception handler within a at controller advice class like REST exception handler.
Handling errors in REST.
It shows an example of handling REST exception and returning a REST error message with HTTP status and other details. Why is structured error handling important in REST APIs?
Exception handling is crucial for RESTful services to provide meaningful feedback to clients. At controller advice allows you to centralize exception handling logic across your controllers.
Global error handling again.
Right. Methods within an at-controller advice class, annotated with at-exception-handler, can handle specific types of exceptions and return appropriate response entity objects, often containing error details in a structured format like JSON. This allows clients to understand the nature of the error and potentially take corrective action, leading to a better API integration experience.
Okay, let's move on to security with Spring Security. Your sources introduce it as a framework for securing Java applications and describe the typical security filter chain in a web application, listing several filters and their roles.
Spring Security, a big topic.
What is the purpose of this filter chain in securing a web application?
Spring Security is a powerful and highly customizable framework for adding security to your Java applications. It uses a chain of servlet filters to intercept incoming requests and enforce security policies.
The chain of filters.
Each filter in the chain has a specific responsibility, such as authentication, authorization, exception handling, and more. This chain ensures that all requests pass through a series of security checks before reaching your application's controllers, providing a robust and modular security architecture. Your materials list key filters like security context persistence filter for managing the security context, various authentication filters like username password authentication filter, authorization filters like filter security interceptor, and others responsible for tasks like remember me functionality, anonymous authentication, and exception handling.
Your sources explain configuring basic web security using security.http with autoconfig true and security.intercept URL to define access rules based on roles.
Basic XML config.
You also need to integrate the Spring Security filter chain in web.xml using delegating filter proxy. What does autoconfig true do, and why is delegating filter proxy necessary?
The security.http element in Spring Security's XML configuration is used to define security rules for your web application. Autoconfig true provides a convenient way to enable common security features with default settings, such as a default login page and basic authentication.
Quick start for common stuff.
Right. The delegating filter proxy in web.xml acts as a bridge between the servlet container's filter mechanism and Spring's application context. It delegates requests to the Spring Managed Security filter chain, allowing Spring Security to take control of the security aspects of your web application.
It briefly mentions testing with an embedded Jetty server using the Jetty Maven plugin. That sounds like a convenient way to run integration tests for your secured web application.
Using an embedded servlet container like Jetty during testing can simplify the process of running and testing your web security configurations without the need for a full deployment to a standalone server.
For authentication, your sources explain using security.authentication manager and security.authentication provider, referencing a user service being implementing user details service.
Authentication setup.
What is the role of user details service in the authentication process?
The security.authentication manager is responsible for handling authentication requests. It delegates to one or more authentication provider instances. The security.authentication provider element, often configured to use a user detail service, handles the process of retrieving user details, like username, password, and authorities, from your application's data store based on the provided username during login.
So user detail service finds the user data.
Exactly. It's a crucial interface that you implement to connect Spring Security to your user data.
The unsuccessful login flow is detailed, involving filter security interceptor, access denied manager, exception translation filter, the login form, username password authentication filter, authentication manager, authentication provider, like DAO authentication provider, and forwarding to the login error URL on failure.
The failure path, yeah.
Sounds like a well-orchestrated process.
Spring Security's authentication process is indeed a multi-step flow involving several components. When a user tries to access a secured resource without being authenticated, the filter security interceptor detects this, and the exception translation filter redirects them to the login page.
Redirect to login.
Upon submitting the login form, The username password authentication filter creates an authentication request and delegates to the authentication manager, which in turn consults the configured authentication provider, like DAO authentication provider, to validate the user's credentials by comparing the submitted password with the one retrieved by the user detail service.
Checks the password.
Right. If authentication fails, the user is typically redirected back to the login page with an error message.
The successful login flow results in the creation of an authentication object in the security context by the authentication provider, which is then stored by security context persistence filter.
The success path.
This sounds like how the user's authenticated state is maintained across multiple requests.
Once the authentication provider successfully validates the user's credentials, it creates an authentication object representing the authenticated principal and their authorities. This object is placed in the security context,
Okay.
which is then persisted between requests by the security context persistence filter, typically using the HTTP session, so the user doesn't have to log in again for every subsequent request within the same session.
You can customize the login page by setting the login page attribute in security.http. And for authorizing web requests, you use security.intercept_URL with pattern and access attributes, using expressions like hasrole, permittals, and others.
Authorization rules.
The order of these elements is important, from most specific to most general. Why is the order of security.intercept_URL elements so critical?
Spring Security allows you to provide a custom login page instead of the default generated one. The security.intercept_URL elements define authorization rules for specific URL patterns using access control expressions to specify the required roles or permissions. The order is crucial because Spring Security evaluates these rules sequentially, and the first matching rule will be applied to the request. Therefore, you should define more specific rules before more general ones to ensure that the correct access controls are enforced.
For managing user details, you can use JDBC-based user details service with security.jdbc user service and configure a data source. It mentions the expected database schema and the customizable queries.
Getting users from the database.
However, it also cautions about transmitting passwords in clear text and the need for HTTPS. Why is HTTPS so essential when handling user credentials?
Spring Security provides built-in support for retrieving user details from a JDBC database using the security.jdbc-user service element. You need to provide a data source and the expected database schema or customize the default queries.
Okay.
It's absolutely critical to use HTTPS in production to protect user credentials transmitted over the network, as basic authentication and form-based login typically send passwords in clear text or easily reversible encoding.
Don't send passwords over HTTP.
Absolutely not. HTTPS encrypts all communication between the client and the server, preventing eavesdropping and ensuring the confidentiality of sensitive data like passwords.
Remember Me support can be enabled with security. Remember-me in security.http, and you can customize the token validity. For enhanced security, you can use a persistent token repository and the persistent logins table.
Remember Me cookies, yeah.
How does a persistent token repository enhance security?
Spring Security's Remember Me functionality allows users to stay logged in even after closing their browser by storing a cookie on their machine. You can configure the duration the Remember Me token is valid.
Okay.
For increased security, using a persistent token repository in a database, like the persistent logins table, is recommended as it prevents against cookie theft. If an attacker steals the Remember Me cookie, they would still need access to the persistent store to generate a new valid token, making it much harder to impersonate a user.
Basic authentication for stateless web services can be configured with security.http-basic in security.http. It's noted that credentials are base64 encoded in an HTTP header and should only be used over HTTPS.
Basic auth. Simple, but needs HTTPS. Basic authentication is a simple mechanism for securing stateless services where clients send their username and password in the authorization header of each request. However, due to the base64 encoding of credentials, which is easily reversible, it should only be used over a secure connection like HTTPS to prevent unauthorized access.
Method-level security can be enabled using the @secured annotation in security.global-method-security. Spring Security checks for the required roles before allowing method invocation using an access decision manager.
Securing individual methods.
You could even test method-level security using testing authentication token. When might you prefer method-level security over just securing your web endpoints?
Spring Security allows you to secure individual methods in your Spring managed beans using annotations like @secured. You need to enable method security in your configuration. Spring Security uses an access decision manager, by default affirmative-based, with voters like roll voter to determine if the current user has the necessary roles to access the method.
Okay.
Testing Authentication Token provides a way to easily set up an authenticated principal for testing method security. Method-level security provides a more fine-grained level of control compared to just securing web endpoints.
More granular control.
Right. You might use it to restrict access to specific business logic within your application, even if the web endpoints are accessible to authorized users. This adds an extra layer of defense and allows for more precise control over what actions different users can perform.
Finally, your sources mention pre- and post-authorization annotations like at pre-authorize and at post-authorize, and pre-post filter annotations, and how to enable them.
Even more security annotations.
These seem to offer even more fine-grained control over security using SPL expressions.
Annotations like at pre-authorize and at post-authorize provide more expressive ways to define authorization rules for your methods using SPL expressions, allowing you to base access control decisions on more complex criteria, such as the values of method arguments or the return value.
Using SPL and security rules.
Yes. At pre-filter and at post-filter allow you to filter the arguments to or the results from a method based on security expressions, providing powerful mechanisms for securing collections and lists.
Lastly, your sources touch on what's new in Spring 4.0, highlighting full support for Java 8 and Java E7 while still supporting older versions.
Spring 4.0 updates.
It mentions how Java 8 Lambda expressions improve the use of row mappers in JDBD template and also method references. How did Java 8 enhance working with Spring?
Spring 4.0 embraced Java 8, taking advantage of features like Lambda expressions and method references to simplify code. The example with JDB template row mappers clearly shows how Lambda expressions can lead to more concise and readable code for data retrieval.
List boilerplate with Lambdas.
Reducing boilerplate and making the intent clearer. Method references offer an even more succinct way to refer to existing methods as functional interfaces.
It also briefly mentions the conditional bean definition model for conditional auto-wiring, the ability to order auto-wired collections of the same type, and repeatable annotations with @scheduled.
Other 4.0 goodies. Spring 4.0 introduced several other enhancements, including more flexible ways to define beans based on conditions using annotations like @conditional, allowing for more dynamic configuration based on the environment or other bean availability.
Conditional beans, okay.
It also added the ability to control the order in which collections of auto-wired beans are injected using @order or ordered interface, and support for using the same annotation multiple times on a single element with repeatable annotations.
With multiple schedules.
Such as scheduling the same method to run at different intervals using multiple @scheduled annotations.
Wow, that was a truly deep dive into a wealth of information about the Spring framework. We covered everything from the foundational principles of inversion of control to building web applications, handling data, managing transactions, testing, aspect-oriented programming, the Spring expression language, caching, RESTful web services, Spring security, and even some of the new features in Spring 4.0.
We covered a lot of ground.
It's clear from the material you provided just how broad and deep the Spring framework really is, and more importantly, why it's such a powerful tool in the Java ecosystem.
Absolutely. Your sources have given us a fantastic overview, highlighting not just the core concepts, but also many of the powerful features Spring offers for building robust and scalable Java applications. It really provides a solid foundation and a comprehensive set of tools for virtually any Java development need.
So for you, our listener, as you process all of this incredible depth and breadth of the Spring framework, take a moment to consider which of these areas resonates most with your current projects or the challenges you're tackling.
Perhaps dive a little deeper into the specifics of Spring security annotations if you're focused on authentication, or explore the nuances of different caching providers if performance is a key concern. The Spring framework offers a vast landscape to explore, and your sources provide an excellent starting point for that journey. Thanks for joining us on this deep dive.